direction, y equals negative 3 halves x cubed. Okay, so to plot this particular cubic function, I'm going to make a t-table in which I'm going to place, let's say, let's put in 5 points into it. So make a t-table, x, y. I'm going to choose to put in the number 0, and I'm going to let the numbers 1 and 2 go in also. So we'll go negative 2, negative 1, 0, 1, and 2. Now, with the cubic functions, as long as they're written in this particular form, ax cubed, we have what's called the odd function property. So what do we get when we stick in 0? Well, negative 3 halves times 0 cubed. 0 cubed is 0. Means we're going to get an output of 0. 1, plug in the number 1. 1 cubed is 1. Negative 3 halves times 1 is negative 3 halves. And when we stick in 2, 2 cubed is 8. 8 divided by 2 is 4. And 4 times negative 3 is negative 12. With odd functions, like x cubes, the numbers that are going in the other direction, when I stick in negative 1 or negative 2, they're not the same value, but they're the opposite of the values that I got when I stuck in 1 and 2. So negative 1 is going to yield 3 halves instead of negative 3 halves, and negative 2 is going to yield a positive 12 instead of a negative 12. Again, this only works in the special form, or not only, but it works here because it's in that special form of ax cubed, a number times x cubed. So now when I come over to the graph, along the x-axis, we'll have to put in 2 spots. So go 1, 2, 1, 2. Up the y-axis, I'm going to have to go up 12 spots, so I think I'll have to scale it a bit here. Let's scale by 5s. So 5, 10, 15, 5, 10, 15, and negative 5, negative 10, negative 15. Okay, so now as I start to plot my points, I see negative 2, comma, positive 12. It's going to be somewhere up there. Negative 1, comma, positive 3 halves, so it's going to be very low, right about there. 0, 0, 1, negative 3 halves, and then 2, comma, negative 12. So the graph here is going to come like that on one side, and then like this on the other side. Okay, so why don't you try one on your own here? Try to draw the graph of y equals 2x cubed. Assuming you paused the video and tried it on your own, let's do it together. I'm going to again start with 0 and choose 2 numbers above and the 2 numbers below. 2 times 0 cubed, well, 0 cubed is 0, 2 times 0 is 0. 1 cubed is 1, and 1 times 2 is 2. And then 2 cubed is 8, and 8 times 2 is 16. Now, since it's of that form ax cubed again, I know that when I stick in negative 1, I'm going to get the opposite of the answer that I got when I stuck in 1. And because of the value of positive 2 yielding 16, negative 2 is going to yield the number negative 16. So coming over to the graph, again along the x, we're going to go 1, 2, negative 1, negative 2. And coincidentally, along the y, since we have to get up to 16, I think I'm going to scale by 5s again. That was not intentional, but it just seems to work here. So 5, 10, 15, and then we'll go negative 5, negative 10, and negative 15. So our points are located at negative 2, negative 16, negative 1, negative 2, 0, 0, 1, 2, and then 2, 16. So unlike the other graph, it looks like this one is increasing over time, whereas the other one was decreasing. But that's in general what the cubic function will look like.